All right, so this is the tutorial sheet for week 5. So as you can see, there are 10 parts to this question. All right, let's start with part 1. So the question is, you have two assets. A portfolio has two assets, right? They are worth X and Y, and you're told that the joint survival function of X and Y is given by this expression, right? And the question are these. The first one is to find the CDF of the maximum of the two assets. All right. Now I hope you know how to do it. Or had you done it already or not? You okay? Nobody is here today. I don't know why. Only 3 of you. All right, so let's start with part 1. Okay. Okay. So that's to find the CDF of M, which is by definition is the probability that capital M is less than or equal to M, which is the probability that maximum of X and Y is less than or equal to M. So if the maximum is less than or equal to M, then each of the random variables, X has to be less than or equal to M, and Y has to be less than or equal to M. You follow me? Yeah? Now, if you were in the review session on Wednesday this week, you will know. Now, what I have written here is the joint CDF of X, Y at M, M. You remember this from Wednesday? Hello, guys. Yeah, now what, if you go back to the question, what is given is the joint survival function. And so, in order to find the joint CDF from the joint survival function, you need to use one of the relationships I talked about on Wednesday, you should recall. You see that I gave you a relationship which expresses the joint CDF in terms of the joint survival function. Okay, which is like this, you should remember. Do you guys remember this from Wednesday? Hello, guys. This is one of the relationships I gave you on Wednesday this week, which expresses the joint CDF in terms of the joint survival function, right? You remember or not? Yeah. Okay. Now this guy, we know what it is because the question gives the formula for the joint survival function, right? So we know what each of these guys is. So this is gonna be 1 minus okay, guys? So that's the answer to the first part of the tutorial sheet. Are you okay with this or not? Any questions? Any questions on that, sir? The sound is low. I don't know how to fix this. I'm trying to fix, I don't know what. I don't know. Anyway, I'll try to speak louder, or if you can hear, if you cannot hear me. Right, so that's question 1. Now question 2 is to find the PDF of M. So PDF is basically the derivative of the CDF. So in order to find the PDF of M, you just need to differentiate the CDF of M with respect to M, right? So you differentiate this guy with respect to M. So you get C divided by, correct me if I'm wrong, right? So that's the probability density function of M. M is the maximum of the two assets, right? Okay, any questions so far on this? Or are you okay? Hello guys, you feel free to ask me any questions if you have doubts. Okay, let's go on to the next part of the question, which is to find the nth. The next question, where are we here? The next part of the question is to find the nth moment of M. Now when I say the nth moment, what I mean is the expected value of the nth power of M, right? Okay, now so let me take this away. Let me also take this away. So this is part 3. Now what we are looking for is the expected value of the nth power of M, right, which is by definition is this, yeah? This is the definition of the nth power. So nth power of M, the expected value. Now we know from the previous part Alright, we know from the previous part that the density function of M is this. Alright? So as you can see, there are three terms for the density function. Right, so basically there are three integrals you need to perform, right? So let me write them down. So the first integral that you need to perform is this, right? The second integrals you need to perform this, and the third integral Alright, so you need to perform these three integrals, and obviously to do this integration you need some kind of substitution, right? And as I said before, it's something that you learn by experience. There's no rules on how to determine the substitutions, but you just have to learn, by experience. So now I will do the following. I will wait a minute. Okay. For the first integral, which is this one, yeah, I will make this substitution. All right, okay, and if you do that, you will get m equal to, okay, and dm by dx will be equal to minus a over x squared, right? All right. Now for the second integral, which is this one, I will make this substitution, right? So m will become b times and dm by dx will become minus b over x squared. And finally, for the third integral, which is this one, I will make the following substitution. Okay, so m will become this, yeah, and dm by dx will become minus ab okay. So these are the three I'm not saying that these are the only substitutions that will work. Obviously these are not the only substitutions that will, you could try other substitutions too, right? And so if you make all these three substitutions into the three integrals, this one, and this one, right, you will get, after some working, after some working, this is what I'm not going to go through the working, but I hope, I'm sure you guys can do better than I do. After making all these substitutions, right, and simplifying things, this is what you will get. Okay, this is what you will get. All right. Now, are you okay, guys, so far, or no? Any questions? Hello, guys. Those on Zoom, you have any questions? Hello. Okay. Now, you may recall one of the videos I did on the course website is about the beta function. So it's defined as follows. The beta function is defined by the following formula. Okay. Now, if you look at the three integrals, this one and this one and this one, they are all the same. Each of these three integrals is the same, right? And according to this definition, the first integral is the beta function at c minus n, alpha equal to c minus n, and your beta is n plus 1, right? So therefore, what you have is the following: c times an times the beta function at, that's the first term, right? The second term is this, and the third term okay. Are you guys with me or not? Hello, talk to me. Those of you on Zoom, if you don't follow, please use the chat room. Okay. Right. So this you can write as C is a common factor. This is also a common factor. So in brackets you have right. So this is the answer to part 3 of the tutorial sheet. Okay. Are you okay or not? Any questions, guys, so far? All right, so that's part 3. Now let's go to the next part. the next part of question. The next part is to find the mean of M, right? So to find the mean of M, you just put n equal to 1. So this is, to find the mean is simply the expected value of M. So you put n equal to 1 into this formula. So it will become C Okay, guys? Alright, so that's part 4. Now part 5 is asking you for the variance of M. Now to find the variance of M, you use the traditional formula, which is, you know the formula for the variance, right? So this is part 5. The variance of M is the expectation of the squared minus the square of the expectation, right? So to find this guy here, you put n equal to 2 into this formula. So you get C okay, and then you take away the square of the expectation, which we already found. Okay, guys, so that completes part 5. Any questions so far, guys? You all okay? All right, now I don't want to do all the solutions. So can you do the next part by yourself, please? I'll give you a few minutes. And you do part 6, which is to find the CDF of L, which is the minimum of the two assets. Can you please take a few minutes and you do part 6 of the tutorial sheet? Okay, guys, can you please do that? Take a few minutes. I'm sure you can do it. I'm sure you can do it. So please try. Do part 6. Hello guys, you okay? Are you guys working on part 6? You guys done? And you guys done part 6 or not? Have you done part 6 yet or not? Not yet. You done? Okay, thank you. So let's see how we get. So let's take this. Hello. So this is part 6. So we want to find the CDF of L, which is the minimum of the two assets, right? So this is the definition. You can write this as 1 minus the probability that capital L is greater than little l, right? So this is 1 minus the probability that the minimum of the two assets is this. Now, if the minimum is greater, then x is greater than L and y is greater than L. Now, if you were in the review session on Wednesday, you will realize that this probability here is the definition of the joint survival function, right? So basically, what you have here is f bar at L comma L. You follow? I mean, did you look at the review session on Wednesday? You will see that. All right. Now, you should go back to the question. The question gives you the formula for the F bar, right? Okay. So this is 1 minus 1 plus L over A plus L over B power minus C. So this is the answer to part 6. Alright guys, now part 7 is to find the PDF or the density function of L. So basically you need to differentiate this with respect to L to find the PDF. So you get, if I'm not mistaken, okay, so that's the density function of L. Part 8 is to find the nth moment of L. So once again you need to find, so let me take this away. So this is part 8. We're going to find the nth moment, which is basically the expected value of L to the power n. So this is the integral from 0 to infinity of, okay, so this is gonna be okay guys, now in order to do this integration, once again we need to make a substitution. So I'm going to use the same substitution that we used earlier on part 3. So for this integral, I'm going to set x Okay, now if you do the working, this will become okay, guys. Right, so if you put this in a box and put this, sub it into this, right, after some working out, which I'm not going to do, after some working out, I'm sure you guys know better than I do, this is what you will get. Okay, guys, now once again, by the definition of the beta function, what you have here, using the definition I gave earlier today, right, this guy here is a beta function at c minus n and n plus 1. So so this is the beta function at c minus n comma n plus 1. Okay, guys, this is clear to everybody. Any questions, please? Including those on Zoom. Please, if you have questions, please use the chat room. Alright, okay, so that's part 8. Now the next part is to find the mean of L. So I can do it here. So part 9 is to find the mean, which is the same as the expectation of L. So what you need to do is just put n equal to 1 into this formula. So you get C Yep. And the last part of the tutorial sheet is to find the variance of L, which, as you know, is this, right? To find this guy here, you put n equal to 2 into this formula. So okay, and then you take away the square of the expected value, which we already found. Okay, so that completes the tutorial sheet. Any questions, guys? Hello, those of you on Zoom, any questions? Sorry. Any questions to all of you on Zoom? You okay, Robert? Alright, the next week is a reading week, so there will be no classes next week, but I will be in Manchester throughout next week, and afterwards also. So any questions you guys have, feel free to contact me by the usual, by email, Skype, Zoom, or phone. And also you can see me in person in Alan Turing. There's issue in Manchester. You can see me. Okay. All right. And so please take care of yourself and have a good break. Right. And I'll see you after the reading week. Of course, you can see me during the reading week too. I will be around. Okay. All right, and I hope all of you got the quiz 3 back. I know several of you didn't get the correct answer. I think maybe all of you here maybe got the full correct answer, but several people had problems doing quiz 3. I don't know, maybe they did not follow my hint or something. Anyway. So just work on the next quiz, which is quiz 4. Quiz 4 is about on portfolio theory. So you should be able to do it, right? But if you have problems, just contact me 24/7. Yeah. Quiz 4 is due after the reading week, so you got 1 week break. You don't have to submit anything next week. I think it will be due after next week. I think it's the 10th or something, 10th of November, if I am correct. Okay, guys. So have a good break and take care of yourself. Right. All right. Hi. How are you?
I'm fine. So basically, I have a question about number 6. So I followed this step actually when I did it by myself, and I substituted these 2 formulas actually. So the answer is actually different. So I'm afraid I made some mistake on the exam.
Yeah, this is correct, but this step is not correct. Because if the minimum is greater than L, then X has to be greater than L and Y has to be greater than L.
I add minus in front. I add minus in front.
Yeah, and also you cannot separate them because X and Y are not independent. See, here you're assuming that X and Y are independent, but which is not the case. Here X and Y are jointly distributed, they are dependent random variables. So you cannot, so this step is not correct. You can't say that because X and Y are not independent random variables, because here you are assuming that X and Y are independent, which is not the case here.
Yeah, I got it.
Yeah.
Thank you.
Yeah. You have a question, sir?
The answer I got is minus.
Minus? Yeah, I think you made a mistake because when you make this substitution,
Yeah.
right, x equal to 0 goes to what? If L equal to 0, what do you get here? If you put L equal to L equal to 0, you get 1, yeah?
Yeah.
So this should be 1,
Of 1.
and this should be 0.
0. Oh.
Right, but then you can use the minus sign, this minus sign here, to change the limits
Yes,
from
yes.
0 to 1.
Oh, yes.
So this sign will be plus. This will be plus.
Oh, okay. Thank you.
Yeah, pleasure. Hi, Matis, how are you?
You decided for the midterm if it was going to be online paper.
I haven't decided yet, but I think it's more likely to be online. It's likely to be online because I don't think everybody will be here.
Okay.
Yeah, I think it will be likely to be online.
Okay.
Yeah. Are you planning to go somewhere or something?
No, I'm just curious.
Okay.
Yeah.
Okay. Okay. Have a good break, man. Have a
You
good. Yeah. See you guys. Have a good break. Bye.
Got class here in 10 minutes. So. Okay,
I'm going to sit here.
What?
I'm going to sit here. So what do you want to sit? You want to sit at that table anyway? Okay. You want to sit here?
I'm gonna sit. So where are you?
Do we have more time?
You can go wherever you want on the table.
I'm just gonna put my bag right next to you, Jim.
I'm not that far.